For our purposes, a mathematical function will simply be a rule by which we assign numbers to points. Those points, as we'll see, can lie in 1 dimension or 2 dimensions or 3 dimensions or any higher number of dimensions. And all we're doing is assigning a specific number to the points, whatever dimensions they lie in. The simplest case of a function is a function that takes points that lie in R1, where R1 is the real line, and assigns numbers to those. We'll denote that as a function from R1 into R1, because we're assigning numbers from the real line to points that are in fact numbers on the real line. We'll illustrate a very simple function here to get the basic concept down. In particular, we'll start with the function f of x is equal to x squared. If we take the point 1/2 on the x-axis, for instance, this function will assign to that point the value 1/4, because 1/2 squared is equal to 1/4. If we take the point 1 on the x-axis, the function assigns a number 1 to that point, because 1 squared is equal to 1. And to the number 2 on the x-axis, the function assigns a value of 4, because 2 squared is equal to 4. Were we to plug each of the values on the x-axis into the function x squared, we would then be able to trace out the full function f of x equal to x squared. In other words, the function that assigns to every value on the x-axis the value x squared. A function such as this, therefore, assigns numbers to points that lie on the real line, on what we've called R1. We could also have a function that goes from R2 into R1. In other words, a function that assigns numbers from the real line to points that lie in R2, in two-dimensional space. In that case, the function would assign a number to each point that lies in a plane, say the xy plane. A utility function over two goods is such a function. It would assign a utility level, in other words a number, to every bundle of goods that contains two items. We'll explore this further in graph 4.8.